Triangles are everywhere. From the pyramids of Egypt to the roofs of houses, this simple three-sided shape is one of the strongest structures in nature. But what exactly is a triangle? Well, a triangle is a closed shape with three sides, three angles, and three vertices. Simple, right? But don't let its simplicity fool you. There's a lot to explore. Triangles come in different types. If all sides are equal, it's an equilateral triangle. If two sides are the same, it's isosceles. And if all three sides are different, you've got a scalene triangle. We also classify triangles by angles. A right-angled triangle has a 90-degree angle. An acute triangle has all angles less than 90 degrees. An obtuse triangle has one angle greater than 90 degrees. Triangles are important because they're the foundation of geometry. In this lesson, we'll explore congruence, similarity, and powerful theorems that help us solve problems. So let's dive in. Now, let's talk about congruence. When two triangles are congruent, they are identical in shape and size, like two puzzle pieces that fit perfectly. But how do we prove that two triangles are congruent? We don't need to compare all six parts, three sides plus three angles. Instead, we use these four shortcut rules. 1 SSS, side, side, side. If all three sides of one triangle are equal to the three sides of another, they are congruent. 2 SAS, side, angle, side. If two sides and the included angle are the same, the triangles are congruent. 3 ASA, angle, side, angle. If two angles and the included side match, the triangles are congruent. 4 RHS, right angle, hypotenuse, side. If the hypotenuse and one side of a right-angled triangle match another, they are congruent. Example: imagine two triangles, one with sides 5 cm, 7 cm, and 9 cm, and another with the same side lengths. By SSS rule, they are congruent. Congruence is useful in real life. Engineers use it to design bridges, and architects use it in construction. Now, let's test your understanding with a quick question. If two triangles have two equal angles and one equal side, which rule applies? Think about it. We'll discuss the answer in a moment. Now, let's talk about similar triangles. Unlike congruent triangles, similar triangles may have different sizes, but they always have the same shape. The rules for similarity are 1 AAA, angle, angle, angle. If two triangles have the same angles, they are similar. 2 SSS, side, side, side for similarity. If the sides are in the same ratio, the triangles are similar. 3 SAS, side, angle, side for similarity. If two sides are in proportion and the included angle is the same, the triangles are similar. Example: a small and a large pizza slice have the same angles. That means they are similar triangles. Why is similarity important? It helps us calculate heights of buildings using shadows. It's used in maps and scale drawings to represent large distances. Let's try a question. If two triangles have sides in the ratio 2:3 but different angles, are they similar? Think about it. We'll answer it soon. One of the most famous theorems in math is the Pythagoras theorem. It applies to right-angled triangles and states. In a right-angled triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. Formula: a squared, where c is the hypotenuse. Example: if a right-angled triangle has sides 3 cm and 4 cm, 3 plus 4, 9 plus 16, 25, so the hypotenuse c is 5 centimeters. Real-life application: this theorem is used in navigation, architecture, and even computer graphics. Now let's solve a question. A ladder is leaning against a wall. The base is 6 meters away from the wall, and the ladder is 10 meters long. How high does it reach? Hint: use the Pythagoras theorem. Now let's look at two important theorems. 1 midpoint theorem: the line joining the midpoints of two sides of a triangle is parallel to the third side and half its length. 2 angle bisector theorem: the angle bisector divides the opposite side into two parts proportional to the other two sides. Example: if the midpoints of a triangle are connected, a smaller triangle forms inside that is similar to the original triangle. Now, let's apply what we've learned with some real-world problems. 1 finding heights using similarity. A tree casts a shadow of 10 meters. A 2-meter pole casts a shadow of 2 meters. What is the height of the tree? Hint: use similar triangles. 2 using Pythagoras in daily life. If a car moves 4 kilometers east and then 3 kilometers north, how far is it from the starting point? Hint: right-angled triangle. Great job! Today we explored the power of triangles, from congruence and similarity to Pythagoras' theorem and practical applications. Triangles are everywhere, from buildings and bridges to art and design. Keep practicing, and soon you'll see triangles all around you. Want to test yourself? Try solving more problems and apply these concepts in real life. That's all for today. Happy learning. That's me signing off.